Welcome to our paper, Fine-Tuning versus In-Context Learning in Large Language Models, from the perspective of formal language learning. Large language models learn in two fundamental ways, fine-tuning and in-context learning. In fine-tuning, the model's parameters is explicitly updated to fit to the distribution, whereas in in-context learning, the model learns from the information presented in the context. Therefore, the following natural question arises. Which learning mode is more proficient in a language or in a new domain or a new task? And whether these two modes of learning differ in their inductive biases. Before we can answer this question, we must address the following three desiderata. Otherwise, our comparison would be inconclusive. Can we precisely define the language or the learning task? Do we allocate equal resources to both modes of learning for a fair comparison? And finally, do we have a comparable evaluation metric for language proficiency? And our answers are formal languages, where we can precisely define the language as well as the learning task. And we are providing identical training examples to both fine-tuning and in-context learning so that the resources are fair and equal. And finally, we are proposing a discriminative test where we can directly compare fine-tuning and in-context learning where the input parameters or the input prompts are processed differently. We are considering probabilistic formal language, which defines a distribution over sequences, and each sequence is generated from an underlying formal grammar. Here on the left-hand side, I show an example of a context-free grammar, which is hierarchical and probabilistic. And the right-hand side shows a sequence sampled from the grammar. And here, the learning task of the learning mode is to generate new strings that could possibly be from the same language. These are some of the usefulness of applying formal languages for a scientific comparison in large language models. In formal language, you can clearly demark between sequences that are inside versus outside the language. And here, the sampling is exact. We can make sure that both training and test sequences are coming from the same distribution. Formal language is all about syntax, so we can eliminate any semantic ambiguity, and their synthetic nature can avoid data contamination. And finally, we can define languages of varying complexity by directly changing the grammar rules. Satisfying all these properties and having this greater control in natural language dataset can be very tricky. Now let's talk about language proficiency test. If we have two different LLMs and a language, which LLM is more proficient in the language? The trivial answer to the question is to directly compare the absolute generation probabilities of the two LLMs on sequences in the language. But the main issue is that two LLMs, which are very different, can have different absolute generation probabilities. So we cannot directly compare it. For example, if you have a multilingual LLM, its generation probability could be lower. Does it mean it is less proficient? Therefore, we are proposing a discriminative test where we are looking into sequences that are outside the language. More precisely, we are saying that in the discriminative test, to be language proficient, the model or the LLM has to generate sequences in the language with higher generation probability than sequences outside the language. So the generation probability of sequences outside the language provides the baseline for comparing the proficiency of sequences inside the language. And this is how we can operationalize this idea. On the left hand side, I show the generative loss of sequences that are in the language, like grammatically correct test sequences, as well as incorrect sequences that are outside the language. And you can see that when the number of examples is lower, there is an overlap in the generation loss. And only after the model witnesses more examples, we can clearly discriminate them. So on the right hand side, we can have a simple threshold-based linear classifier to see what fraction of test sequences can be discriminated. And you can guess that we can easily design the hardest discriminative test where we want to compare sequences that are different by a small edit distance, like edit distance 1, which makes a grammatically correct sequences to and grammatically incorrect one. And we can also argue that this discriminative test can avoid any model specific or prompt specific biases. Now let's look into some of the experimental results. Here we have picked one language and try out multiple LLMs from different families and sizes uh, through fine-tuning and in-context learning. Interestingly, we find that in fine-tuning, all the models are converging to equal proficiency. However, in in-context learning, there is more variability. And when we compare fine-tuning and in-context learning directly, we find that across different scenarios, fine-tuning is better in terms of the discriminative performance than in-context learning. However, when we are thinking about out-of-distribution generalization, meaning that the model learns one language, but it tries to generalize other nearby languages, we find that both fine-tuning and in-context learnings are performing almost similarly, and they can only generalize to languages that are closer. Therefore, the proficiency of fine-tuning in distribution generalization over in context learning does not translate when we are considering out of distribution generalization. Finally, we are also comparing the inductive biases. We're asking whether different modes find it equally easy or difficult to generate a set of sequences. And here, interestingly, we find that when the language proficiency is lower, denoted by this smaller circle, the correlation is much higher. But when different modes of learning becomes more proficient, the correlation decreases, meaning that when the learning modes become more proficient, they learn in a different way. So in summary, we have shown that the discriminative test can be comparable across multiple LLMs as well as different learning modes. And we also carefully study situations where fine-tuning can be better than in-context learning as well as comparable. Check out our paper for more details. Thank you.